All right, and welcome back. So here's a quick do now for you. Is 4 comma 0 a solution of the following system? This system of equations consists of 2x plus y equals 8 and negative x plus 3y is equal to 4. So is 4 comma 0 a solution to the system? If you substitute in x and y in each equation, do you get a true statement? All right, so let's check to see if 4 comma 0 is a solution. We're going to let 4, that's our x value. I'm going to note that in red. And 0 is our y value. I'm going to note that in blue. When we substitute into each equation, we have 2 times our x value, which is 4, plus our y value, which is 0, which should have been in blue. Come on, we can do this, technology, is equal to 8. Well, 2 times 4, that's 8. We have 8 plus 0. That indeed is equal to 8. So far it works for one equation, but we have to double check the other equation. We have the opposite of our x value. Our x value is 4 plus 3 times our y value, which is 0. Well, the opposite of 4 is negative 4. 3 times 0 is 0. It's equal to 4. Is negative 4 equal to positive 4? No, it is not. So therefore, 4 comma 0 is not the solution of the system. Awesome. And speaking of systems, previously we learned how to solve a system of equations by graphing. So if we have two equations, we have y equals 3x plus 2 and x plus 2y is equal to 18. We know that we can graph these and see, hey, where do these points intersect? We call that the point of intersection. In this example, it happened to be 2 comma 8. And this is one way about solving systems of equations. We can use this graphing method. But here are some questions to consider. Is graphing a good way to solve a system of equations? What problems have you run into when using the strategy of graphing to solve a system of equations? Please let me know below. You can be as honest as you want to here. So today's goal is, after reviewing prior knowledge on solving systems of equations, I will be able to solve a system of equations by using the substitution method. Today's topic is all about the substitution method. And last class, we worked on it a little bit using that graspable math, where we were able to move around some terms and show some arithmetic on an interactive platform. Well, we're going to be using the knowledge that we discovered from that, and today we're going to be formalizing it. So please make sure at the top of our notes we have substitution method. Before we go through examples, let's talk about the exact steps we're going to take. So please copy down these 7 steps. These 7 steps are the steps to solving a system of equations via the substitution method. If at any point in time I say, hey, what are the 7 steps to solving a system of equations by substitution? You should be able to have out your notes and say, boom, here it is, 1, 2, 3, 4, 5, 6, 7. And the order in which they appear is, the first thing we need to do is isolate if necessary. We're going to need to get a variable all by itself, as you've seen already, to use this substitution method. Step 2 is we're actually going to substitute. Step 3 is we're going to distribute if necessary. Step 4 is we're going to combine some like terms. Step 5 is we're going to solve for that first variable. Step number 6 is substitute and solve for the second variable. And step 7 is check. So let's use these steps here to help us solve 3 examples of how to solve systems of equations using the substitution method. Here we go. Let's go through some examples. Example number 1. We have y is equal to 2 and x plus 2y is equal to 18. Looking at the 7 steps we need to do, the first one is isolate if necessary. We need to get a variable all by itself on one side of the equal sign. That way we can substitute it into the other equation. Well, looking at this, we already have y all by itself, and we know y is going to be equal to 2. So what we're going to do is we're going to use step 2, substitute this value of y into the other equation. So it's going to look like x plus 2 times 2 is equal to 18. Now we're going to distribute if necessary. Well, we can do 2 times 2. That gives us 4. So we have x plus 4 is equal to 18. We're going to combine some like terms, but we don't have any like terms to combine, so we can skip step 4. Now we're going to solve for that first variable. So we want to get that x all by itself. We're going to subtract 4 on both sides. Therefore, we get that x is going to be equal to 14. Now that we solve for that first variable, we're going to substitute and solve for the second variable. Well, this step is already done for us. We already know what y is equal to. We know that y is equal to 2. So therefore, our coordinate point is going to be 14, comma 2. 14 is the x value, 2 is the y value. But now we need to double check. Well, we're going to go back into both equations, but in this case, we're only going to go into that blue equation because the y equation is already done for us. We have x plus 2y is equal to 18. We're going to substitute in our x value, which is 14, plus 2 times our y value, which is 2. That's still equal to 18. Let's double check. We get 18. 14 plus 4 is equal to 18. And we know 14 plus 4 is indeed 18. So we know for a fact that 14, comma 2 is going to be the solution. Let's go through another example. Whoop, went too much. The red equation is y equals x plus 2, and the blue equation is 3x plus y is equal to 10. Let's reference those steps that we need to take in order for us to solve the system using substitution. Well, the first step is isolate if necessary. We need to get a variable all by itself. Well, we already have what y is equal to. Y is all by itself. It's isolated in that red equation. So y is equal to x plus 2. So we're going to substitute the value of x plus 2 into the other equation where we see y. So it's going to turn into 3x plus, in parentheses, x plus 2, and that's equal to 10. We're going to distribute if necessary. Well, there's no number on the outside of the parenthesis. It's only 1. So if you want to show multiplying by 1, you can, but there's nothing really happening here. So let's drop those parentheses. All right. We're now going to combine some like terms. 3x plus x is equal to 4x. We have 4x plus 2 is equal to 10. Now we're going to solve for that first variable. We're going to get that x all by itself. In order for us to do that, we have to subtract 2 on both sides. We end up with 4x is being equal to 8. Therefore, we have x is going to be equal to 2. Let me show that with a different color here. Boop, 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 boop. What color should we choose? Oh, I haven't used gray in a long time. Let's use gray. We're going to divide both sides by 4. Ooh, that's a great color. So we have x is equal to 2. Now that we solve for that first variable, we're going to substitute and solve for that second variable. We have this y is equal to x plus 2 equation. We're going to take the value of x and substitute it in. So instead of writing x, we are again going to be writing 2 plus 2. Therefore, we get that y is equal, let's choose a different color. Ooh, let's use this gold, yeah. So y is going to be equal to 4. Therefore, our coordinate point is going to be equal to 2, comma 4. And now we need to double check and plug these in to both equations. Well, we have y is equal to x plus 2. The y value is 4, so 4 is equal to the x value, which is 2. Ah, I missed the gray. Here we go. 2 plus 2, and we get 4 is equal to 4. Awesome. But now we need to double check the blue equation because we have a system. Just like we saw on the do now, one coordinate point could work for one equation, but doesn't always work for both. So we have to double check and make sure it does work for both. We have 3x plus y is equal to 10. We're going to substitute in our x and y values. Well, our x value is 2 plus our y value, which is 4. That's equal to 10. We can simplify. 3 times 2 is 6. 6 plus 4 is 10. Therefore, 2 comma 4 is indeed our solution. Awesome. Let's go through one more. Example number 3. We have two equations here. X is equal to y plus 10 and x is equal to 2y plus 3. Looking back at our steps here, we need to isolate if necessary, but looking at this, we already have a variable isolated. We have in the red equation, x is all by itself, and that's equal to y plus 10. Also, in the blue equation, x is isolated, and x is equal to 2y plus 3. So what we are going to do is we're going to substitute into the other equation. We're going to take this value of y plus 10, and we're going to substitute it into the other equation for x. And you're going to see that we end up with y plus 10 is equal to 2y plus 3. And just to give you another visual for that, y plus 10 is the same thing as x because they're equal. 2y plus 3 is the same thing as x because those are equal. So x is equal to x. Something is equal to itself. 2 is equal to 2. 5 is equal to 5. Negative 427 is equal to negative 427. Whatever it is, it's equal to itself. So we can set the other two parts of the equations equal to those. So now we're going to distribute, but we don't have anything to distribute this time. We're going to combine some like terms. We don't have any like terms to combine on one side of the equal sign. And now we're going to solve for the first variable. So we need to get our y terms on one side of the equal sign and our constant terms, the terms are without the variable, on the other side of the equal sign. I noticed that 2y is bigger than 1y. So let's leave that 2y all by itself. So we're going to subtract y on both sides. We're going to end up with y plus 3 is equal to 10. Now, you might have moved the 2y. That's totally okay. We're both going to end up with the same answer, bearing all the algebra is done properly. Now that we have our y term on the right, we need to move that positive 3. We're going to have to subtract 3 on both sides, and we get that y is equal to 7. Knowing that we have y is equal to 7, we're going to now go back and substitute and solve for the second variable. This is step number 6. We can pick either equation, the red or the blue. It doesn't matter, but I'm feeling kind of blue today. So let's use the blue. And not sad. I'm just really digging the color blue, but thank you for your concern. So we have x is equal to 2y plus 3. We're going to substitute in the y value, which is 7. We get that x is equal to 14 plus 3. And we get that x is going to be equal to, let's go back to that gray again. It's going to be equal to 17. So now we have our coordinate point. We have 17, 7. Just going to fill it in the color scheme. But now we need to double check and make sure that this is true. Well, we go back to our original equations. X is equal to y plus 10. We're going to substitute in the x and the y values. Well, our x is 17. That should be equal to our y value of 7 plus 10. 7 plus 10 is indeed 17. So it checks out for that right equation, but we got to check that blue equation. We have x is equal to 2y plus 3. We're going to substitute in our x and our y values. Our x value is 17. That's equal to 2 times our y value plus 3. Our y value is 7. 17 is now equal to 14 plus 3, and therefore 17 is indeed equal to 17. So our final answer, the solution to the system is 17, 7. Great job with this, kiddos. You're doing really well. Keep on working on this. This is a process that if you just follow the steps and you have these examples and you use your notes to reference you, you are going to be an absolute stud and a baller and a shot caller and a fantastic student. I don't know. These endings are getting out of hand. Great job. If you have any questions, please do not hesitate to let us know. I'll talk to you soon.